so we're just going to practice some of these trig inverse, and E stuff, and I'm just going to grab your homework. I got a few problems on here and go through them, and I think you guys will be set if I just do that. So if I look at this first one here, cosecant of 2x to the 5th. You can use your chain rule, or you can do, kind of just think through it. I'll do chain rule with the u du first. So I would call u equals 2x to the 5th. That means du will equal 10x to the 4th. And then, so y equals cosecant of u, derivative of that, so the derivative of cosecant is negative cosecant cotangent, and the u goes in both spots, and then you took the derivative of a u, so you multiply by du. You only multiply by du once. You don't multiply by it twice just because it's in like two different spots. So cosecant of the u, cotangent of the u, then times du, and then you put everything else back. So cosecant of 2x to the 5th, cotan of 2x to the 5th times 10x to the 4th. So the other way would be if you just looked at this and said cosecant's my big guy and 2x to the 5th is my little guy. You take the derivative of cosecant, which is negative cosecant cotangent. You leave the little guy alone, which is the 2x to the 5th in both spots, and then you multiply by the derivative of the little guy. So whichever way is working for you is cool with me. Let's say number 4, y equals sine of 4x squared. So again, you can go u equals 4x squared, du equals 8x. Rewrite the original as sine of u. The derivative is cosine of u times du, which would be cosine of 4x squared times 8x. Or you could look at it and say, okay, that's the big guy, so I'm going to take the derivative of the big guy, leave my little guy alone, and then multiply by the derivative of the inside. All right, so that's a couple trig examples. Trig inverse, really similar. I can do it either way. So I could look at this and say u equals 3x to the 5th, which means du will equal 15x to the 4th. And then rewrite this as cosine inverse of u. The derivative of cosine inverse is negative because it starts with a c, 1 over the square root of 1 minus u squared, but I took the derivative of a u, so I multiplied by du. Then I replace, so it would be negative 1 over the square root of 1 minus 3x to the 5th squared times 15x to the 4th. And the only thing I would ask you to do to simplify would be just write this as one fraction. So this is really like times 15x to the 4th over 1. And if you multiply by straight across, you just end up with the 15x to the 4th on top of the square root of all this nonsense. And you don't have to, like, you can leave this part here. You don't have to square that. And you probably just make your life harder for no reason if you did try to. So leave it like it is. Again, you could do this kind of just reasoning through it. So you can say, okay, I know the derivative of cos inverse. Take the derivative of the big guy. Derivative of cos inverse is 1 over the square root of 1 minus. Leave the little guy alone, squared, times the derivative of the little guy. I think the u makes a little more sense in this one than it does in some other ones. It's just a lot to keep track of, but, you know, it's up to you. Let's say 15. So I could say u equals 5x squared, which means du equals 10x. Therefore, y equals tan inverse of u. Well, the derivative of tan inverse is 1 over 1 plus u squared. But you took the derivative of a u, so times du. So plug the u back in, multiply by du, and then again, I would just want you to write that 10x on top. And you are not expected to expand that stuff you don't have to square that. Sorry. And again, you could just look at that, and this is easier for some people than others, but the derivative of tan inverse is 1 over 1 plus blah squared, where blah is the little guy, and then you multiply by the derivative of the little guy. So whichever way works best for you, that's what I want you to do. Same idea with e's and ln's, which we've kind of done before, but I don't know if I've ever put them like on the video. So I could look at this and say u equals 4x squared. Du equals 8x. So y equals e to the u. The derivative of e to the u is e to the u times du, which means e to the 4x squared times 8x, and that's my answer. You could also look at the original problem and say, okay, my big guy's e. When I take the derivative of e to the something, it just stays e to the something. And then I multiply by the derivative of the little guy. So thinking through it is tougher. It can be faster, but I think it's harder. So if you're doing that, make sure you're getting them right. If not, I might jump back to the u method. 24, similar. I can do it either way. So u, I'm going to call 3x plus 4. Du would be 12x to the third. So the problem is really the natural log of u. So the derivative of that is 1 over u. But I took the derivative of a u, so multiply by du. So it's 1 over 3x to the fourth times 12x to the third. Let's write it as one fraction, so 12x to the third over 3x to the fourth. And you could actually stop there. That's a legitimate answer. On the multiple choice in the AP, they would probably put 4 over x. So 12 over 3 is 4, and you'd have like 1 extra x on the bottom. Again, you could do that with kind of shortcutting it, just thinking through it. So the big guy's ln, the derivative of ln of something is 1 over the something. Then you multiply by the derivative of that something, and you could kind of jump to this spot. But I think that's a little tougher. Just kind of up to you on if you're successful at it or not. All right, so do 1 through 30 here, and I'll answer questions tomorrow and keep them up.